Hey everybody, we're here to talk about problem solving in Python today, and we're going to be using the Knock Knock Jokes um, project to do this. So let's take a look at that. So here's the Knock Knock Jokes project. This is my final version, and I'm going to run it just so that we see what's involved with this. So the first thing you're told is that the program is ready to tell knock-knock jokes and tells you there are 7 available, and then asks you how many jokes you would like to be told. And excuse me. And it says there are 7 available, and so if I were to put in 8, it should tell me the number must be in the range of 1 to 7. So it catches that error, and it would also catch an error if I typed in something that wasn't a number at all, and it says enter a valid whole number from 1 to 7. So how many jokes would you like me to tell? Well, let's go ahead and ask for one. So if I ask for one joke, knock knock, the computer says knock knock, and now I say who's there. Or if I were to type in the completely correct response, it would be who apostrophe S THERE question mark. So that would be the perfect response. And then cows say, and then for this I would say cows say who, and like that, that would be the perfect response to that. And it says no, cows say moo, owls say who. So that's the punchline telling the joke. If we were to run this again, so F5, so if, and I ask for one joke again, now I should get a different joke. So, I mean, there's a 1 in 7 chance that I might get the same joke, but in principle, I should get a different joke. So the odds are on my side. So let's see. So knock knock, and this time I'll type in um, a variant who's there like that. So notice there's no punctuation involved, there's no capitalization, but it still gets accepted. And then it says Dwayne, and so I should say Dwayne who, but instead I'm going to just say Dwayne like that. Now that's an input error, and so it will ask me to tell me the correct response is Dwayne who, and to try again. And so now I will type in the correct response, Dwayne who, and again, it's agnostic to capitalization and also punctuation. So I type in Dwayne who, and it gets accepted, and it says Dwayne the tub before I wound. Okay, so that's the way my program works, and that's what I can expect to see um, in your submission. So if we go back now to the presentation, so we want to talk more about problem solving here than about coding. So when you're given a problem, what do you have to know about the problem? You have to analyze it. So the joke consists of 5 lines, right? We've been through that. And one line delivered by the computer, and the next delivered by the user, and next delivered by the computer, the next delivered by the user. So we have a pattern of give a prompt, get a response, give a prompt, get a response, and then finish up. So finish meaning the punchline. And so the initial problem solving activity is to think about the problem and recognize the patterns here. And then the next step is to deconstruct each one of these patterns into simpler ones if that's possible, and to fit each pattern into some combination of a Python data structure and also Python programming construct, okay, or algorithm. So let's see what we got here. So this is our roadmap. This is our specific output, and this is our pattern of outputs. And so if we try to recognize patterns, we sort of ignore a lot of the details, like what the specific thing is here. The fact is that this is something printed, this is something typed by the user, printed, typed by the user, printed. So we ignore those details to get to the heart of the problem, and each detail is going to have its own pattern that we can address later after we take a look at these other patterns. So the most prevalent pattern associated with this Python construct is that we deliver a prompt and we get a response, and then we finish up. So prompt, response, and again that repeats prompt, response, and then finally we just print something out. So this prompt response pattern repeats, which means, well, and it does so with different strings. So the prompt here is knock knock, but the second time the prompt is tank, and then the appropriate response is who's there in the first time, and tank who in the second time. But so each time this repeats with different strings, and that suggests that this might be a good application for a function. So if we just had a function that did something called prompt response, we would pass in some parameter prompt, so that would be a string, and so and um, and we'd print that, and then we'd get some input response. But so what? This is very simple, a very simple function, and we're not quite sure what to do with the response at this point. Um, so should it just return the response, or should it process the response in some way, or should it just ignore the responses, just like getting it enough? So if we decide to process the response, then we would try to determine if the response is correct. And but we don't have enough information here to know if the response would be correct or not. We have to be able to compare it with something. I need some kind of template, or a bunch of templates. And so we could use a collection of correct responses, so meaning a list of strings, and then pass that in as a parameter. So if we did that, now we would have a function that looks something like this. So we'd have prompt response, and we'd pass in a prompt, and then we would also pass in a list of acceptable responses, and we would have to compare with that. So so as we go through this process of analyzing how much should this function do and what should it do, um, every time we come up with another idea to improve on this or to add to it, um, each decision leads to another question, and that's okay. That's pretty much what we do when we try to solve problems with a machine. And so here we've gotten to this point where we're passing in a prompt, we're passing in responses, and we still have not compared the response we get from the user with the responses in the parameter that's been passed in. So we need to decide what we're going to return. So let's just agree that we're going to return true if the response is correct, and false if it's not. So so to do that is pretty easy. So the response is correct if it's present in this collection of responses, and so um, Expressing this in Python is easy. The expression would be response in responses, which means here we would just return this. So we would print the response, we would print the prompt that we're given. We would obtain a response from the user, and then we would compare that response to the list of responses that were given, and we would return if response is part of that or not part of that. And so this would return true if the response were correct and false if the response were not. Um, Still, this function is only 4 lines long. It's pretty simple. Um, could we have it do more? Yeah, we could have it do more. So the function has a context, right? And the context is this main program that we're talking about. So right now, the function delivers the prompt and gets a response and determines if the response is correct, and then returns the state of that response. Um, and so now this true or false value goes back to the main program. And what would the main program do with that value? Well, one of the things it would probably do is uh, is say, well, give some feedback to the user that says, um, your response was incorrect, and here's what you ought to type. This is an example of a correct response. But we could have the function do that um, by just passing in a third parameter over here that's a suggestion, something that we can use as feedback to the user. And so here, if we expand this function one more time, now we have the prompt and the responses that we use to determine correctness. And now we have this suggestion. So to use that suggestion, we would only use it if the response were incorrect. So here, if the response is in responses, then we return true. But if not, then we print a message that says the correct response is, and we print that suggestion, and then we say try again, and we return false, letting the main program know that in fact the user did not type in the correct response. So now the function looks pretty complete. It has some responsibility, but not too much responsibility. We're not passing in a lot of parameters. We're passing in some, and most importantly, some of the things that I see in student work is that they'll write a function that depends on global variables, that is, variables that are not passed in, but this function doesn't do that. Okay, so it doesn't have too much responsibility, and so we can write this and test this. Excuse me. And so we would do it this way. So here's the function. Here's where we call it. So we assign the the return value to a variable called OK, and then we print OK. And and here we're testing it with lines 1 and 2, right? So line 1, it's going to print knock knock, and then line 2, we're going to expect a response that could be who's there with an apostrophe, could be who's there without the apostrophe, could be who's there without the capitalization of the W. And if the user produces a response that isn't any of these, we're going to use this suggestion and feed that back to the user. Say, well, the correct response is who's there. And so to test the function, we call it with some realistic data, and then we run several realistic test cases. So the thing that's going to change between these test cases is what I type in after I get the prompt. So here I type in here I get the prompt knock knock. I type in who's there like that, and who's there is present in the responses, so it returns true. Good. So now the next one, I get the prompt knock knock, and I type in what, and of course that's not correct. So the function goes down here and says the correct response is who's there because I passed in this suggestion, who's there. It says try again and returns false. So we get it to return true by giving the correct input. We get it to return false by typing in an incorrect response. And so here now I get the prompt knock knock, and I type in who is there. Now maybe who is there is a correct response. But in fact, the function is telling me it's not because who is there is not in this list. So maybe we ought to add who is there to the list of responses. So that's part of the process. Is as you go through testing, you may find that you need to modify some of the criteria in your code to make it more friendly. So let's see. So finally, in considering the function, we have to make some agreements. So one is the responses are all processed in lowercase. So if we make this agreement, then we make things simpler for ourselves, and um, and that the responses are processed without regard to punctuation. And both these agreements or assumptions will make things easier for us later because they reduce the number of correct response cases that we have to pass in. So now we don't have to pass in uppercase and lowercase, and we don't have to pass in apostrophes, and we don't have to pass in exclamation points or question marks or whatever, because what we'll do is we'll remove the punctuation from the response we get. But removing this punctuation from the response is going to require a little bit more processing. So that means we're going to have to alter the function a little bit. Removing punctuation is a relatively general problem that you may run into like more than once in your programming career, and so it may warrant the development of a small function that removes common punctuation. So let's try and write this function to implement removing the punctuation. So to do this, we start with a string that contains common punctuation. I'm not going to make this exhaustive, but some of the punctuation that is common that we might want to remove is this apostrophe or a comma or a period, a question mark, an exclamation point, maybe a semicolon, and maybe a double quote as well. So I precede that double quote with a backslash, meaning that it doesn't serve as the end quote. It serves as a double quote character in the string. And so now we need to use a for loop to traverse whatever string we want to test. And we'll copy each character to a new string only if it is not in P. So P is this punctuation string. And and it's important to understand that we have to make a copy because a string is an immutable object, right? We can't just remove it from the string. We need to actually just copy the characters we want to a new string. So, so when I did this in the shell, so here's my P, which contains my punctuation marks, and then here's my new string, which I starts out as a null string, and then here's a response string that has both um, regular characters and punctuation in it. And so now I have my loop for C in response. So so this traverses this string character by character, and then we test. So if the character is not in P, not punctuation, then we um, concatenate it to new string. And so all of the characters that are not punctuation get concatenated to new string. And in the end, when we print out new string, you see the punctuation is gone. This was removed, the space was included, this was removed, the space was included, this was removed, the space was included, this was removed, and it's the end of the string. Excuse me. So now we have this clean function. We can make a clean function that removes the punctuation. So um, it accepts the string as an input parameter and returns a string without punctuation. So we did it with a for loop in the previous page, but we could also use something called a list comprehension. And the list comprehension looks something like this. So starts out with a square bracket and ends with a square bracket, indicating that whatever this ends up being, it's going to be a list. And then this says for C in response, so C for C in response, if C is not in this, our string of punctuation. Now this creates a list of characters that are not punctuation. It doesn't create another string. To create another string, we have to use the join method. So um, we take a null string and we invoke the join method. And in that join method, we pass this list, and all the characters that are in that list will become the new string. And so the shortest version of a clean function would be something like this, where we return the string, which is the joining of this list. And this list consists of characters, all the characters in S, that are not punctuation. Okay? So that's how to read that. And as we go forward in the course, we'll do a lot more with list comprehensions because as you can see, you can do a lot in a single line of code, and it's not so bad to read. Okay, so so now if the punctuation is removed and the response is converted to lowercase, then the function call for lines 1 and 2 in the main program would look something like this. Prompt response. Knock, knock. Who's there? Who is there? Who there? Who dare? So notice that this list of responses has changed. There are no capital letters in any of the responses, and there's no punctuation in any of the responses because this list assumes that we've converted to lowercase and that all of the punctuation has been removed. And then who's there is the suggestion. So this list no longer needs to account for case or punctuation. Okay, so now Back to problem solving. So we'll return to the big picture now. So as we tell the knock knock joke, we have this pattern, and then we have the pattern again, and then we print the punchline. So we recognize the prompt response pattern, and we developed a function to handle it. And there's this new pattern. So so if so one call of the function handles these two lines, a prompt response. If it returns true, we move on to the next one. But if it returns false, we go back and we deliver this again. We repeat the current step. So now repeating something implies that we need a loop. And there are a couple of ways to repeat things. So if we say repeat until something is a success, then that implies that we should use a while loop. And if we say repeat something for a particular number of times or a particular number of objects, elements, then that implies that we use a for loop. And so here we have repeat this until success, and then repeat this until success. And so each one of these blocks is going to consist of something that says while not prompt response. And the parameters we pass will be different, but basically um, um, it's simply calling this function and continuing until prompt response is true. So this repeats until the user types a response that matches one of these responses. And the same exact pattern happens here with lines 3 and 4. So now we've got to talk about data structures. So far we've used strings, so a prompt and a response and a list of strings, responses. Um, but now we need to consider how we're going to represent a joke. And a joke consists of two unique and interconnected parts. They're a pair of values. Those parts are the prompt and the punchline. So in the case of the joke we've been working with, um, where the prompt is tank and then the punchline is you're welcome, those two things would have to be connected together, and we can do that in a number of ways. But note that the the joke responses. So although in lines 1 and 2, the responses were just a string, here in this particular case we need to compute the joke responses. So we can use a list or a tuple equally well to pair the prompt and the punchline together. Um, if we do that, we need to define a format. So we could put the prompt at index 0 and the punchline at index 1. And so our tank joke example would have joke is equal to, so this makes a tuple, putting things in parentheses. So here's our prompt, tank, and here's our punchline. You're welcome. And if we made it with as a list, it's the same thing, tank and you're welcome. So tank is at index 0 and you're welcome is at index 1. So that's just one joke. But we want to tell more than one joke. And so we'll want to make a list of jokes where each element is a tuple representing one joke. So we can have a variable named jokes, which has many tuples, and each tuple represents a particular joke, which is a punchline, a prompt, and a punchline. The data structure you choose matters. If you choose the right data structure, it makes your program easier to write and it makes your code more readable and maintainable. So this is not a trivial decision here. This is an important decision. So so now I have the body of a program that will tell one joke. It's going to do prompt response 2 times and then finally end up giving a punchline. I want to be able to test this in a rigorous way moving forward because if my code is bad here, then my code is going to continue to be bad moving forward. Um, so I'm going to create this body of a program, and then I'm going to run some tests where I type in obviously good and obviously bad responses. And the good responses should move smoothly from one part of the joke to the next part of the joke. And the bad responses should keep me stuck until I give a good response. Then if these tests are satisfactory, I know that the code I have is sound. And more importantly, any future errors will be due to new code that I add, not old code. So once I've determined that I have some code, I've written some code that I've absolutely tested and I know is working, I don't want to go back and change that code. So, so here's one test. So with just one joke, right? Ready to tell a knock knock joke. So knock knock, who's there? Tank, tank who? You're welcome. So all of these responses are correct, and I move smoothly from lines 1 and 2 to lines 3 and 4 to the punchline, and then I end. Thanks for playing. But now I need to test with some bad input. So here knock knock, and then I type this junk, and it says the correct response is who's there. Try again. And so then I type in who is there, and notice I put in the punctuation, and and I move smoothly on to the next part of the joke, and then I get this prompt tank, and again I don't give the correct response. I type tanks a lot, ha ha ha, and the correct response is tank who. I get that message, which is correct, and then I type in the correct response, and then I get the punchline. You're welcome. Thanks for playing. So that worked out fine. And again, I can test again with this time giving an incorrect response or an incorrect response, getting a suggestion, using the suggestion, incorrect response, getting a suggestion, using the suggestion, and the program finishes fine. So so I know that this sequence of prompt response in while loops, and then having then delivering the punchline and ending the program. That whole process works. So now we can now I've tested the program body. So I want to add to it. But I don't want to mess with it because if I mess with it, it's something that I know already works. So why would I mess with it? I know it's good code. So um, what do I need to add? Well, let's see. So we need to add more jokes. And we need to add a way to choose the jokes. And we need a way to randomize the jokes. And a way to choose the number of jokes to tell. And excuse me. So adding the jokes. So you can make a list called jokes and then append a tuple for each joke. So here's two. So jokes, make an empty list. then append to it. Here's the tank you're welcome joke, and here's the cows say joke, and I can append however many jokes I like as long as I have a prompt and a response to provide in a tuple. So choose the jokes. So how do we do this? So once we've appended all of the jokes, we traverse the list in a for loop. So we haven't gotten to the point where we're choosing the jokes yet, but as or specifying a number of jokes. But once we've appended all of the jokes, then we can traverse the list in a for loop. So for joke in jokes. And this will present the jokes in the order they've been appended, and the program body will get executed inside this loop. So we have the while loop that calls the prompt response. We have a while loop that calls prompt response. Then we deliver the punchline. And if you want to change the order of that the jokes get told, you can use a function called shuffle, which is part of the random module. And so, but to traverse the list, we just use a for loop, for joke in jokes. We don't need to use an index as we would in other programming languages. So now if we want to randomize the jokes, we can shuffle the jokes by calling the shuffle function. So we import shuffle from the random module and then shuffle the jokes. So from random, we import shuffle. And then we pass in our joke list, our jokes, as a parameter, and those jokes get shuffled in place. So each pair is an item, and each pair stays together, but the order in which they sit in our list of jokes gets changed. So now we want to tell a certain number of jokes. So the maximum number of jokes we can tell is the number of jokes we've appended to our jokes data structure. So the maximum number we can tell is length of jokes. So it's a good practice to tell the user the maximum number of jokes that are available, and then ask, how many jokes would you like me to tell? Now, when you do this, you'll probably need to catch a runtime error and respond appropriately using try except block, and we've talked about that in the past. So let's call the number of jokes n jokes. So we have an int variable called n jokes. And if the number is valid, then meaning that what is typed in is actually a number, then we can check that variable n jokes against the length of jokes. And if n jokes is greater than length of jokes, well, then we've got to remind the user of the maximum and loop back and ask for the number of jokes again. And we continue to do that until n jokes is at least 1, greater than 0, or up to being equal to length of jokes. Once you have a valid number for n jokes, then the way you tell a certain number of jokes is to take a slice, not of n jokes though, take a slice of jokes that matches the request. So here's jokes equal to jokes from the beginning all the way up to n jokes. So you've already gone ahead and shuffled these jokes, and now you're going to take the first n jokes from that. And so now when you go in your for loop for joke and jokes, it's going to have the correct number of jokes to tell and run out of jokes after end jokes have been told. Okay, so final testing. I showed this to you before, so this is one result from my tests. I tested every number of jokes up until the maximum of 7. And I tested with typing errors in lines 2 and in line 4. And as I did that, I found that, like, each test is an opportunity to improve the look and feel of the program. So for example, um, it's good to have a blank space here um, to separate the jokes. Um, it's good to have a message that says I'm ready to tell 2 jokes. And those things came to me as I was going through this testing, and I made those small changes. So here's the thing, and here's the message I want to pass on to you is that we want to now focus on the design of our program, the problem solving aspect of writing code, and not so much the code. Um, the design choices that you make, they're going to determine how easy or difficult it is to write the code as a solution to any problem. And the design is based on those patterns that you recognize as you go through the problem, as you deconstruct the problem, and the data structures you choose to use. And the programming exercises that you've gone through, those little exercises, they're all very important, but um, they're important in that um, it allows you to not focus on the code now. It allows you, now that you're relatively fluent in coding, it allows you to focus more on problem solving and data structures. And so if you've been doing the exercises up until this point and ignoring the narrative of each chapter that goes through solving a particular type of problem, it's time to go back and look at that and try to catch up. Um, because to focus on design and not code depends on your ability to be fluent at the code. And to focus on design, the only way to really do that, to get good at it, is to experience some design examples and see how other people have approached the solution to a problem using Python. Okay, so that's it for this video, and um, I hope this sets the stage for the next few weeks where we're going to be diving into some more advanced aspects of the language. So I look forward to seeing your work. Take care.